We want to demonstrate practical the way it should be done. Neco question number 2, part 5. This is the diagram of a rectangular prism. This is the model of a rectangular prism. The ray here, we call this one incident ray. In the air, this is refracted ray in the glass prism. This is the emergent ray in the air. We are provided with a rectangular glass prism. This is the one students are using. This type, so the one students are using. This is the model teacher we use to demonstrate for you now after the question. Optical pins. These are optical pins are small one we use to paste the paper. This is a drawing pin. This is plain sheet of paper. This is plain sheet of paper. This is protractor. This is protractor. This is right angle triangle. This right angle triangle. This is long plain ruler, 30 centimeter in length, and this is cellulose drawing board. This is cellulose drawing board. Now, trace the outline ABCD of the glass block on a sheet of paper. Remove the glass block. Mark the position N very close to A, about 2.0 centimeter. 3. Draw the normal at the point N. Draw an incident ray such that the angle of incident I is equal to 20 degrees. Fix 2 pins at point P1 and P2 on the incident ray. Replace the rectangular prism and fix pins at P3 and P4 such that the pins appear to be in a straight line with the image of the pins P1 and P2. When filled through the side DC of the glass block, remove the glass block and join the points at P3 and P4, producing the line to meet DC at F. Join NF. Measure and record the angles of refraction R and emergent E. 10. Repeat the procedure for 5 different values of R is equal to 25 degree, 30 degree, 35 degree, 40 degree, and 45 degree. Tabulate your readings. State 2 precautions to ensure accurate results. State Snell laws of refraction. Plot the graph of sin I against an R and determine the slope. Given that the refractive index of the material is N and that N-1 is equal to slope, determine the refractive index. Now, let me demonstrate how to perform the experiment of this rectangular prism. First of all, we place the rectangular prism on your drawing board, drawing sheet, your plain sheet of paper. After that, you remove it. You name it A, B, C, D. You use your plain 20 centimeter ruler to measure 2 centimeter from A. If it's 2 centimeter, you draw a number at that point. Then, after that, you use rectangle and protractor to measure the angle angle of incident, which is equal to 20 degrees. This is 25, that is 30, this is 20 degrees. You start from here. The whole here should be on this point where it normal meets AB. So you now count to the bar 0, 10, 20. This is your 20. You jump into the point where normal touch line AB. Then you put your pin here, P1, as you can see, P2, about 2 centimeters distant from one another. There should be an arrow here. This arrow must be there to tell you that this is incident ray moving from here to the glass door. Then you put a pin, drawing pin here, put a drawing pin here, another one here. So you now replace the glass casing. You replace the glass casing. When you replace the glass casing here, you now check the pin. You use another pin 3 to locate the images of the P1 and P2 here. At the point where you locate the image, you put the pin P3 there, P4 there. So after locating it, you remove the rectangular casing. You draw the pin, you draw the point P1 and P3. You join it together. This is P3. This is P4. Then you draw a perpendicular to DC. That is normal. This is your N. According to the diagram, this is your N, this is your F. Then this is P3, P4. This is incident ray. This is emergent ray. According to this is the angle in between the incident ray and the normal is called angle of incident. And you join point N to F. When you join that together, the angle in between the refracted ray and the normal is called angle of refraction. This arrow shows that it is moving from here to the glass casing and back to A, where it emerges A. Now, this is the complete experiment. Now, in order to measure this angle, we've measured this one before we start. To measure this one, we are going to use angle of refraction. This is, we are going to place your protractor like this. This O will be on this point where normal join AB. So you now start reading. This is 0, 10, 18. This is 13. Now, then to measure the angle of emergence, you do the same thing. This 0 will be at the point where the normal join DC. Then you measure it. This one is 20 degrees. So, yes, right. I just use this one to demonstrate how you are supposed to perform the experiment. I've already performed the experiment for 6 or 20 I, angle of incident 20 degrees. degree, 25 degree, 30 degree, 35 degree, 40 degree, and 45 degree. And these are the values I was able to get. I will write the values now and use it to plot the graph. R is 13.00. When angle of incidence is equal to 20 degree, angle of refraction is 13.00. Angle of emergence is 22.00. When angle of incidence is 25 degree, I was able to get 15.00. Angle of emergence 28.00. When it is 30 degree, I got 18.00. And emergence 25. Yeah. This is 23. Sorry, this is 23. 25.00. When angle of incidence is 35, this is 20.00. And emergence is 28.00. When angle of incidence is 40 degree, I got 23 here. And with the angle of emergence, I got 35.00. When angle of incidence is 45, I got 26 here. While angle of emergence is 42.00. Now, these are the value of sine I. These are the values of sine 20. Sine 20 is 0.342. Sine 13 is 0.225. Sine 25 is 0.423. Sine 15 is 0.259. Sine 30 is 0.5. Sine 18 is 0.309. Sine 35 is 0.574. Sine 20 is 0.342. Sine 40 is 0.643. Sine 23 is 0.391. Sine 45 is 0.707. Sine 26 is 0.438.